Okay, so good afternoon and welcome to this second live talk on UI engineering. So these talks are a bi-monthly event that are organized by the IFIP Working Group 2.7 13.4 that focuses on user interface engineering. So we invite members or experts to share their view and work on different aspects of this discipline. Today, we have a talk about conversational recommender systems that will be given by Jürgen Ziegler. Jürgen is a senior full professor at the Computer Science Department of the University of Duisburg-Essen, and he is also an active member of our IFIP working group. So Jürgen, please, the floor is yours.
Thank you very much, Davide, and welcome everyone. Thank you for attending my talk about design and engineering issues in conversational recommender systems. I want to talk about some of our recent work. Of course, not all the work that is done in this area. I've only a relatively short time, so I will focus on developments and studies that we have been doing recently in that area. I think everybody should be aware of what recommender systems are. They are fairly ubiquitous in many application domains, such as media, of course, e-commerce, but there are also recommenders for running routes and things like that. So essentially, they help users to find suitable items in very large sets of alternatives. Now, typically recommenders are one-shot, so you have some user profile that has been captured in the past, and from that the system generates some recommendations which the user can accept or disregard or reject. But recently there is more interest on a type of recommenders that's called conversational. And a very well-known description by Dietmar Janach and others says that conversational recommenders, short CRS, are software systems that support users in achieving recommendation-related goals through a multi-turn dialogue. So you will notice that this is a fairly open definition, and of course there are various instantiations of what CRS are. So for instance, there are GUI-style advisor-like recommenders that lead the user through a series of questions which they can answer. But they are usually using a predefined dialogue sequence, which makes it hard for the user to express interests that are not in the current dialogue flow. Then we have the typical text-based chatbot-like recommenders, which are sequential dialogues between user and system, which can also contain some GUI elements. And in some cases, they are also strongly guiding the user in eliciting preferences. So preference elicitation is very much guided in these systems. And that is also a reason why they are particularly helpful in cold start situations when nothing is basically already known about the user. But there is a wide range of potential design options, modality. For instance, you also, I forgot this one. Critiquing RS is also a style of conversational recommending, where users can react on the recommendation shown and say that they would like to change some feature of the recommended item. And concerning modality, of course, we have visual CRS and we have voice-based CRS. But in this talk, I will only focus on visual CRS and not touch upon voice-based CRS. But interaction style, level of adaptivity, language understanding are all factors by which different CRS actually differ. So there's also the notion of interactive recommending, and it is not always easy to distinguish that from conversational recommending. So there are interactive recommenders like the one that you see on the left-hand side, a system we built some time ago where users can influence movie recommendations by selecting and weighting tags and rating different movies and immediately seeing the changed recommendations. So here users can access the different interests they have quite in parallel. So that gives them a high level of control and flexibility. On the other hand side, typical conversational recommenders are sequential, which creates a strong sense of guidance, but on the other hand allows to express things that are not so easy in the interactive recommending case, for instance, to carry out dialogues at a task level, so rather what the item, what the product, or whatever it is will be used for. On the other hand, mostly have typed input, which is usually often considered as inefficient. So, but we may come back to some of these issues a little bit later, but I will focus more on the right-hand side parts of the conversational aspects. So my first issue, or I call it challenge here, is how to interact with the CRS. And the first question is actually related whether it's purely text-based or whether it includes also other elements. On the left-hand side here, you see a typical text-based CRS where everything is written output by the system and typed input by the user. On the other hand side, you may have systems that create response suggestions to the user, which are often shown by GUI-elements such as buttons or sliders, which on one hand side act as cues for the user to elaborate their preferences, to really think about what they want. On the other hand side, they are of course more efficient because it's just a click versus the typing. But still, there are some issues that are not clarified. How far can you take the principles? So we also recently developed the idea of inline critiquing. Critiquing, as I said a bit earlier, is you see a product, an item that is recommended, and you can change some of the properties of that item, which basically means I want something like this, but maybe with a different color. But you might also actually do that right in the conversation when the recommender outputs some assumptions about your preferences. You might directly select in the text a different value. And this is what we call inline critiquing. Now, this is a sort of proposal that we wanted to investigate, and we did a study on these mixed modality CRS, first looking at whether purely text-based CRS are preferred or mixed modality interaction, and also looked at which style for the critiquing would be used. This was done still in the Corona times, so we did that with a video prototype and 70 prolific participants in 2 groups between subjects, and captured a number of responses through questionnaires. Now, what becomes very clear from this study is that GUI responses are really preferred over textual user responses because it's much quicker, and they win basically on all relevant criteria such as efficiency, enjoyability, even precision, and supportiveness. For the critiquing, we found that users prefer critiquing controls attached to the recommendation, to the recommended items, rather than the inline critiquing. But the inline critiquing also has some advantages over simply free text input. So overall, item-based critiquing was preferred, but inline critiquing also wins against pure text in a number of cases. Now, this study has a limitation. It was just video-based, no real interaction, but it creates also an interesting question, which is users like these GUI shortcuts as responses, but if we offer them, will that possibly prevent users from specifying other or more preferences in text, even if the system is able to understand that? So do we narrow down the path by which users develop their own preferences? And I think that question is really still open. Somehow related to this, we were asking ourselves the question, do users actually interact with recommenders? Really, what are they interacting with? And I would claim that they are rarely interacting with a recommender. They are interacting with an app. and recommenders are merely a component in the entire app. So in the app may offer additional techniques for search and filtering, but recommender systems research has mostly considered as standalone things, at most using them as a source of implicit feedback, like clicks, views, or purchases, but not considering what the user is doing in the rest of the app in terms of searching and filtering. So here we made the proposal some time ago to combine CRS with faceted filtering and do that in a seamlessly integrated manner. And the technical approach, how we do that, is that we integrate the CRS and the filtering by means of a knowledge graph. So when users answer a question in the CRS part, that will automatically select suitable values in the filtering component, and vice versa. If the user selects some values in the filtering component, that will influence which question will be asked next by the CRS. So this should be, as we believe, closely integrated. And this also corresponds to different user goals and different user knowledge, because in some cases, users will simply know the features that they want of a product, and then it is much more efficient to just select that in a filtering. In other cases, they are maybe vague about their goals and just would like to know which product is suitable for a certain purpose, for which a filtering component is maybe not ideal. So the combination, we believe, is quite promising. And we do that in a graph-based approach. I don't have the time to talk about all that, but we basically connect items, the features that they have, the values that are expressed in the features, and also link them to the questions and answers that the system can exploit for carrying out the dialogue. So based on that, we build a system, actually, which may look a little bit complex, but not all these components are visible at the same time. Basically, you have a GUI-based dialogical conversational recommending part, which asks the user some questions, for instance, the usage of laptops. In this case, we did it for the domain of laptops. And once the user selects an answer here, that immediately highlights here visible in green some filter values, and also shows which filter values are probably not so suitable for this answer, shown in purple here. And to show the connection, an animated arrow appears that shows this connection. So there are further components like sliders that also show the distribution of how many products are available in a certain range, which corresponds to the faceted filtering notion. And then you get recommendations here, as usual. Of course, once you do a change here, you have an immediate update here. But based on that, you can also have different sorts of explanations, but they only appear on demand. So in reality, the system, the screen looks a bit less overloaded as it may appear here, which shows everything. So again, we tested this and against a conventional system where also filter and advisor were available, but they were not connected through a knowledge graph. So first of all, we saw that comparing concerning the general user experience, both systems were comparably good. So at least that showed that the sort of increased maybe complexity of the connections in the hybrid system did not negatively affect the user experience. But we saw that the integrated system increased trust, increased acceptance, and also increased the transparency of the advisor, because users could immediately see the impact of choosing an answer to a system question on the feature values in the filtering component. So generally, we believe there are some advantages to this integration, but we also saw that users can be sort of clustered in two groups. One group more using the advisor part, the other group using more the filtering part. This may be depending a little bit on the domain. We have only tested it in one domain so far, laptops, but we will continue also looking at other domains with this concept. The second issue or challenge I would like to talk about is about explaining recommendations. There's always been seen a need to explain at least a little bit why certain things are recommended, and you may have seen such simple explanations on popular websites like Amazon, like things like customers who viewed this item also viewed other things. But these are fairly shallow explanations, which may not lead users to fully understand what's going on. So deeper explanations are typically needed. So we also, again, did a series of studies on explanations, and we were especially looking on review-based explanations. So reviews based on explanations based on customer reviews, using aspect-based sentiment extraction. So customer reviews mention different aspects of an item, different features of an item, and we extracted those and also captured the sentiment connected to that aspect. We did first a number of single-shot explanations, looking at different type of textual explanations from reviews like aggregation, summary, or helpful reviews. Aggregations are well-structured descriptions of the overall review set for a recommended item, showing percentages. So for instance, cleanliness in this case, this is a little bit small probably to see, but cleanliness was mentioned positively in 92% of the reviews and so on. So this was the most preferred one. Summary would just merge all that into a single textual description, and just showing the most helpful review also was not accepted that well. So aggregation seems to work quite well. We also looked at different ways of displaying this information, especially in a table, bar chart, or textual format, again, with these review-based aspects and sentiments. But in a second study, we could not find a main effect of display style. Also, we could not see an effect of showing explicitly the assumed user preferences in a user model, which was a bit surprising, but we couldn't see a main effect here. So, but all these studies so far were single shot, so not really conversational or interactive. So we now continued investigating explanations which we framed as interactive argumentation, and we drew upon a couple of concepts from argumentation theory to back these developments. And we did this again in different interaction styles. The first one being a GUI style interaction, where from a set of recommendations that you see here, you could click on links that lead you further in an explanatory chain, showing such survey data or aggregated data for different aspects. If you would like to see more aspects, you could expand that, and then you could drill it down actually to excerpts from individual reviews that were either about the whole thing, the whole room, or you could actually also select single aspects like what is the quality of the bed as reported by customers. So we have this chain here of interaction, and users could drill down as far as they wanted. And here, again, we did a study with first, again, 3 display styles as previously, and as a second factor, high and low interactivity with 170 subjects between subjects design. And what we saw is that the interactivity, the high interactivity version, actually significantly increased perceived explanation quality, also the effectiveness of the recommendations, and the trust users placed into the system or these recommendations. again, we did not see a main effect of presentation style. So this apparently didn't matter that much. But we saw some effects of personal characteristics, for instance, especially decision-making style. We were measuring decision-making behavior of people with a well-known scale, the decision-making scale by Hamilton. And you can see that actually, while for the low interactivity, actually there was no real difference in the rating, so explanation sufficiency here. But the higher the rationality score on these scales was, the more users, participants appreciated the high interactivity. So it seems to be also a bit user dependent, which style is actually preferred. But in any case, we could see that also as a main effect, the interactivity increased the perceived quality of the explanations. So this was still in a GUI style, but of course we also wanted to look at a conversational style with textual interaction. And for that, we built a conversational explainer in a text-based interaction style, which generates recommendations and also explanations based on reviews. We detected responses based on intent detection by training a BERT model, actually, first initially in a sort of off-the-shelf method. But then we also started collecting questions by users, which they provided in an open style. So we did a study where users could ask anything about a set of recommendations in the hotel area. And so we collected about 1,800 questions from about 300 users and started classifying these questions to find out what users are actually interested in knowing about the recommended items, in this case, the hotels. And the first finding we had, I find really interesting. We classified first into domain related intents, so domain related questions and system related questions. And really the vast majority of questions was about the domain. So people wanted to know more about the hotels shown. So does Hotel A have a pool? How is breakfast in Hotel B and stuff like that? And only very few questions sort of asked about the system, in the sense of how were these recommendations created, which data were they based on, and so on, which is very often the idea in XAI that this is what people are mostly interested in. But what we see here is pretty much a different picture. So we went on to further classify the questions along 4 dimensions: scope, comparison, assessment, and detail. And just to mention a few, we see, for instance, that about a third of the question is not related to a single recommendation, but to more than one recommendation, like is Hotel A better than B? Or are the beds in C better than in D? Stuff like that. Also, we found quite a number of comparison questions, like the one I just mentioned. There are different types of assessment-related questions. Some really factoid. How far is the hotel from the main station? How was your impression of the room per se? And also some questions about why recommend it, but not in the sense that these questions related to the algorithm. And mostly users also wanted to know about individual aspects of the hotel. So the restaurant, the room quality, the bed quality, stuff like that, and not just of the overall hotel. So this really gave us a lot to think and raised the questions whether users really want transparent algorithms. My take on that is that users, if it is afforded by the domain, want to explore more about the recommendations themselves and use their own judgment to find a suitable item, rather than asking about how did you come up with these recommendations. So this is in one domain now, but I think this gives us some hypothesis about what might be going on in others, but we still have to check that. And this is, I think, still also a sort of challenge for CRS research. So the conversational explainer, we based after training the system with these questions, was analyzed again with a high level and low level of interactivity. So this is a higher level of interactivity where things are split up in a sequence of questions and answers. But in the other condition, users could simply ask in an input box more about a certain hotel. So we made a little distinction again in the degree of interactivity. And we again compared that in the GUI navigation, which I showed you before, which looked like this, and tested it against this natural language conversation in high and low interactivity style. Had 162 online workers in a 2x2 between design with either high or low interactivity and different types of explanatory interfaces, GUI style or natural language style, and tested that on a number of outcome variables. And what we see again, maybe surprising, maybe not, that interactivity had a large main effect on outcome variables such as explanation quality, transparency, effectiveness, not so much, but on trust. So apparently this is really an important factor. And much to our surprise, I must say, we didn't see a main effect of interface type. So whether users use the GUI navigation or the natural language style interaction didn't really show in the output variables, outcome variables that we have been looking at. So this is an interesting thing, and maybe also gives some incentive to think about how such conversational recommenders, even if they are using high capabilities of language understanding, how they should be built. Should one transform some of the outputs or potential user reactions more into a GUI style navigation? An open question, but here is a big question mark underneath these findings. Again, we saw a moderating effect of a personal characteristic, in this case, visualization, familiarity, higher familiarity with visualizations gave more preference to GUI navigation, as you can see in this picture. Now, the final issue or challenge I would like to address is a work that we have started recently, which is sort of ongoing and not finished, which is about adapting to the individual. So what can we actually adapt to the individual in CRS? Well, there are a number of factors one can think about. So for instance, whether it is more a system initiated or user initiated dialogue scheme. So many systems start with the system asking some questions to the user, and the user just responds. But in the other case, user initiated, users can just freely start asking questions. Do users prefer longer sequences or shorter sequences? I'm not going to read them all out here. Should the system respond with long sentences or short sentences? Should it embed GUI elements and stuff like that? And then there are also, of course, maybe potential preferences at the recommendation level. So well-known factors such as high and low diversity of the recommendations, a long list or short recommendation list, more or less features of the recommended product that are shown. So these are a number of the issues that may be different for different users. And to investigate this, we came up with the idea of the concept of meta-intents. Intents usually in CRS is detecting the concrete preferences, for instance, about products all the features of these products. This is what is usually meant by intent detection, which is related to the items the user would like to have. We propose meta-intents as a concept that relates to the user preferences in terms of how to interact with the CRS. So these are more high-level factors that reflect the user's preference about how to conduct the conversation, actually. So a different type of intents, but also something that is related to the user's goals and wishes and preferences. So we did a fairly large study, actually 2 studies here with about more than 600 people altogether, with first an exploratory phase, exploratory factor analysis, and secondly, a confirmatory factor analysis. So we started out with 59 questions for 12 hypothetical meta-intents we could think of or extracted from the literature. But our confirmatory analysis ended up with, with 8 rather stable factors that we found. So these are the following. I'm not going to read that all out to you in the interest of time, but there's, for instance, efficiency-oriented, so finding a suitable product quickly is the most important thing for these users. Goal focus, do users rather have a clear goal of what they want, or they are developing their preferences while they are, for instance, shopping? Initiative preference, should the system take the lead, or should the user take the lead? Interest in detail, how much information do they want to see about the products? Do they want to compare things? Scope of choice, how many recommended products do they want? And maybe just to mention the last one, which is also often discussed, how human-like should the CRS appear? Should it appear like a human conversation partner with greetings and politeness in the dialogue, stuff like that? Or should it be more sober and neutral, actually, in the interaction style? So these were the ones that sort of survived our factor analysis work, and we believe it could be interesting if we can use these factors for adapting CRS. Of course, here the question is how to detect these things. Well, first of all, from the exercise that we did, we have now a quite nice questionnaire for asking users about their meta-intents. Maybe one could do that up front, but in real cases, you probably would like to infer the meta-intents from their interaction behavior, which is, of course, quite a bit more difficult interaction behavior and the textual utterances that they produce. We also analyzed these factors in a structural equation modeling approach to see whether there is, again, impact of the decision-making behavior of people, and indeed there is. So with a higher rationality, there's also higher interest in details, a higher interest in scope of choice. So I want to see more recommended items, and also I want to see more explanation. Intuitiveness is clearly positively related to human likeness. So they want to have a more human-like appearance of the CRS, and they are also efficiency oriented. This is actually a finding we found in several studies, that with higher intuitiveness, people become more efficiency oriented. Efficiency oriented means they don't want to spend much time actually in finding a suitable product. We didn't find really an influence of age. Gender only had an influence on human likeness. So females had a higher put a higher weight on the human likeness of the conversational agent. So these are psychological and demographic factors that influence users' preferences here in terms of meta-intents. But we went on also to, in a study, to analyze the interaction behavior and how it would relate to the meta-intents. But these results are still fairly initial because we only had single interaction runs actually, and maybe these meta intents can only be really detected if you observe several searches, several interactions of users with the CRS. So at least we saw that initiative preference, so the stated initiative preference in the questionnaire by users, was strongly correlated to users changing the initiative mode. So if they preferred user initiative and the system started out in system-initiated mode, they very quickly switched to user-initiated and actually stayed in user-initiated mode, while the system-oriented ones changed less, but then switched more frequently between the modes. The stated efficiency orientation led to viewing less recommending products, and especially also interest in detail. The higher the interest in detail, the longer the overall duration of the conversation, also longer total time in checking details. They are viewing more recommendations, they're performing more critiquing actions. They pose a larger number of questions, so longer sequences of the dialogue. And they also type more, interestingly. So they type longer input sentences. So that's all these significant correlations. But now, of course, and that is the next steps that we will be looking into, is how to make use of that to detect these meta intents from the conversations in more or less in real time, and how to adapt the system accordingly. But we see here an interesting starting point for tailoring the CRS more to the individual user and maybe the current context of the interaction. So these are the three sort of areas, challenges, issues I wanted to address. But to conclude, I just wanted to briefly I cannot omit that, talk a little bit about what's next. And of course, we cannot avoid a discussion of large language models at this point. And we are really, I think, at the beginning of a new era. And it will definitely also very much influence the recommendation area, and of course, especially recommending these conversational recommenders. Just to show you a little initial study that we did already is a couple of years ago, we developed a preference elicitation method, which is based on collaborative filtering, from which we extracted latent factors and showed examples of items, here movies, that correspond to a high or low weight on a certain latent factor. Of course, latent factor means you don't understand what it really means. So we attached a set of tags, user-created tags, to these sets of movies to explain a little bit what these factors mean. Now we did exactly the same experiment again, but this time we had GPT 3.5 create descriptions of these sets of movies. They were still created by collaborative filtering, extracting latent factors, but then asking GPT to create a sort of a virtual genre description of the movies on the left-hand side and on the right-hand side here of this choice. And the overall system works like that users walk through a sequence of such choices, typically 4 to 5, which gives them already quite precise personalized recommendations. Now, these descriptions here are in German, and you may not understand it, but I can tell you that they are really good. And also, we did the first experiment where users judged them much better on all UX dimensions that we applied against this tag-based approach. So I think they hold at least great promise for explaining recommendations. So this is probably a game changer. And to wrap off, these systems will also be used as proper recommenders, not just as explainers. And here's an attempt, not from us, but from a group that built a system. And here we're really getting into engineering issues that created a full system, which includes components for prompt construction, from user profiles, item attributes, and user item interaction. Different tasks can be injected. GPT works on this input, recommends something and describes it, but then there's also the question how to format the output. What is the right output format to present these recommendations, or in the end also explanations? And I think this is a challenge. Maybe the output of such a large language model could also be maybe transformed into some GUI components from which the user can select in the next step. So we are I think, just at the beginning of this development, but I have the firm belief that this is really changing the game. And you may have had a look at things like Google Bard that came out recently. And I tried it also just a couple of days ago. Unfortunately, this is in German again, but basically I asked Bard, recommend movies with humorous content and show me 5 recent films, 5 recent movies. And this is the output. Absolutely plausible 5 recommendations with a very good description of the content. It's not personalized exactly why I would like it, but at least in content summarization, it's pretty good. So I guess we will see much more of this, and even more interesting challenges will arise from that. So with that, I would like to conclude. Thank you for listening. And of course, I'm open for questions, and I hope there are some. Finally, some references if you are interested in some of this work. Thank you.
Okay, thank you very much, Jürgen. If there are questions from the participants, you can just turn on the webcam and ask. Okay, maybe I will break the ice. So I found very interesting the fact that actually one of the main factors that help the user in recognizing the recommendation as useful was basically the fact the interactivity of the information, but not the way the information was visualized. And in my mind, these two aspects are usually quite related to each other. So I can provide a certain level of interactivity in the information representation as long as I select one visualization. Can you explain something more on how you split these two aspects for
yeah, I mean, we had several studies actually looking at this interactivity versus presentation style. In the first one, it was simply GUI based, and the interactive part had this relatively long sequence, which I showed you. Maybe I can go back to that. And this, of course, requires more clicking. Where is it? I'm sorry. Coming close. So this here. This requires more clicking, but on the other hand side, it allows users to drill as deeply as they want into the descriptions. And I think since the different visual explanation styles, so bar charts, tables, or text, contain more or less the same information, the factor whether there is more interesting information in the details that you get through the interactivity was more important than just the visualization style. Of course, this may change if you have even more difference in the presentation and if it is not fully equivalent, but we aimed at full equivalence basically in the display styles. And in the less interactive style, low interactivity condition, we simply packaged more of this information into a single output. But that possibly overwhelmed also users a little bit, so that they wanted to see that in portions. And so for many, of course, I don't have the data here, how far they went into these interactive explanations. But even at the first level, they get a reasonable overview of how other users rated the different aspects of that hotel. But when somebody like myself is particularly interested in the bed quality in the rooms, and I still have a chance to go down and see that in a very selective manner. Of course, this dialogue must be rather focused and really follow a clear line of, that is why we called it argumentation. You just do not just show more, but you have a sort of logical line that leads you into the details. And I think this was the beneficial aspect of this type of interaction.
Okay, one more chance for more questions. There is Jose, maybe?
Yeah, I was just, because I was thinking about this, and it seems a lot depends on how the information is structured.
Mm-hmm.
And so I was thinking whether if you had a non-interactive presentation where you structure the information in the same way as it is structured in this interactive one, so that you first had the overall view, and then the progressively you had more information, but which people could scroll, for instance, whether that would give a similar result as this one. Well, you haven't tried it probably, but what do you think about that? So if it's interactivity or just the way the information is structured in the
Well, in the end, the interactivity means structuring the information. You're absolutely right. And of course, in each step, we show a different aspect or more detail on some aspect. So it's inevitably connected, of course, this interactivity, what we call interactivity, with structuring the information. In the low interactivity case, we would package more, as you say, in a single display. But first of all, that apparently did not serve all users well. So if we know, for instance, that the more intuitive ones didn't drill down that much into the detail in information, while the more rational ones actually did. Secondly, we sort of avoid by that a certain information overload. Of course, there is still a certain trade-off, because you have to do interactions, you have to click on these links and make sense of the upcoming new information. But at least from the feedback we got, and this was really an online interactive study, so not just by showing things, we at least get the feedback by users through the different outcome variables that they really prefer that. And sort of equivalent content in different display styles didn't make really that much of a difference. Actually, it didn't make a significant difference.
Okay, thank you.
Okay, I see Fabio that raised his hand. So you can turn the webcam on and ask the question.
Hi, Jürgen.
Hi.
Interesting talk. No, I was curious about, the conversational part in this recommended system, and, the possible exploitation of tools such as ChatGPT, which is now widely discussed. No, because in the system you showed at the beginning, the conversational recommended system, the dialogue was not particularly, say, conversation. It was more. And so I was wondering whether, exploiting this kind of tools would allow for more, let's say, natural conversation, richer, with more, let's say, flexibility. What do you think?
Yeah, your voice comes a little bit low, but I hope I understood it. Yeah, basically, well, in the first studies, we saw that users will really like these shortcuts, avoiding textual questions. But of course, on the one hand, we have to see that as a preliminary result, because so far chatbots have been really very limited in their understanding capabilities, and that is why many people really didn't like them. And the sort of GUI style interaction was much more accepted because it avoided these problems. You didn't ask questions the system could not answer. And secondly, it helped you to find your preferences because you saw the options that are there. But it also narrows down the search space for the user. So I think this will probably change if you have a better language understanding and responding capabilities, as these large foundation models offer nowadays, or can offer. But there is still the question of how much users want to spend on typing their preferences. So I think it could really be an interesting question. Give the input to a language model, create some output, maybe generate either text or maybe directly something else, but maybe translate it into something that the user will find more efficient. And possibly helps them more also to express their own preferences. In many cases, users do not have clear preferences. So they are sort of in a general shopping mood and want to see what is there. And only once they see it, they make up their minds, this is something for me. And of course, for those, a user-initiated dialogue with the system just asking, tell me what you want, is not very helpful because users do not know exactly what they want. So I think it is an interesting maybe trade-off and question in the future, how we could solve two things. Well, high level of understanding of user intents from their questions, but also supporting them well in cases they do not know enough about their own goals, really. And also, if they are not willing to type a lot, there's still many people who are not really fond of typing a lot. And of course, if it slows down, simple keystroke analysis is still there and I think valid, and pressing the button is quicker. But finding a trade-off between this flexibility and the efficiency, I think will be one of the interesting issues to look into. And I think we're on the at the beginning of exploring that.
Okay, thank you.
Okay, so yeah, I think that this concludes this second episode of the live talks. So thank you again to Jürgen to this very, very interesting talk. And yeah, in the end, I'm also glad to announce that I will be the next speaker for the live talk in September. I'm Davide Spano from the University of Cagliari, and the talk will be about easing the development for the XR development for novices and users. So yeah, thanks again for attending this live talk, and see you in September.
Also, thanks from my side for attending. Hope to see you soon in person again.
Thank you very much. Bye-bye.
Bye.